So this is the unit test review. One quick note here, this is version 1.1. I did make some small changes to it. About 95% of the problems are the same, but I did fix a couple problems that had some issues, so you may see some slight changes. This version is on Backpack, and it's also uploaded to the drive, so you can import it to Notability if you want to. Okay, so the truth tables for and or. Remember, and is the strict parent. This is strict, right? And this is not so strict, right? Not strict. That helps us to remember the example we used in class, which was you have to do your homework and you have to take out the garbage for this first one, okay? So this symbol, of course, stands for and. This is the and symbol, right? This is and. So basically what we're trying to say is, in this column here for this truth table is, did you take out the garbage and did you do your homework, right? Or I think we had, I think the first one was homework. Yeah, I think the first one was homework. So we said homework and garbage, right? So did you take out the garbage? Yes, I did. Did you take out did you do your homework? Yes, I did. So that means you did both things. You did this and this, okay? You did both of these. The second one says you did do your homework, but you didn't take out the garbage. So when your parents say to you, did you take out the garbage? Did you do your homework, and take out the garbage? You said, well, no, not really, not mathematically. Because mathematically, it has to be true for both, right here for and. Okay, this one, you didn't do your homework. You did take out the garbage, though. But again, when your parents ask you, did you take out the garbage and do your homework? The answer is no, I did not do it. And of course, if you didn't do anything, we know that that's also going to be false. Okay, let's contrast that with or. So or is this symbol. This is the symbol for or. And we call this a disjunction. The other one was a conjunction. So or is a not so strict parent, right? So this parent says, listen, just if do your homework or take out the garbage. If you do either one, that's great. So obviously if you do both and they ask you, did you take out the garbage or do your homework? You said, yeah, of course I did. But even in this case, right? So in this case, you did your homework, you did not take out the garbage. So your parents say, did you do your homework or take out the garbage? And you're like, yeah, I did that. Yeah, I did one of those. I did one of those. And same thing for this one, of course. Now, the only time you're going to get a false here is if you didn't do anything. So if you didn't take out the garbage, if you didn't do your homework, then even the not so strict parents are going to say, well, that's an issue. So it's false. So these are the two truth tables for and or. Make sure you memorize those. Okay, and now we're going to apply them to some actual problems here, right? So given the statement, if you do your homework and you don't fool around, be careful, there's a negative there, right? So if you do your homework and you don't fool around, then you will get an X box, okay? So determine, and I changed the wording here a little bit on 1.1 to make it a little clearer. Determine what you can be absolutely sure about, okay? So, number 1.1, right? 1.1. Bob fooled around. Okay. He fooled around, and they told him not to fool around. Okay. So, what do we know? Did Bob get an Xbox? You'd like to say no, and there's no way that we know he got an Xbox, but he might have gotten an Xbox, right? This sentence doesn't say he can't get an Xbox, but we can't be sure that he did. We also can't be sure he didn't. So, although a lot of you probably chose B here, Bob did not get an Xbox. It's possible he got an Xbox for a different reason. They're just saying he will definitely get an Xbox if you do both of these things. And he didn't. So the answer actually is no way to tell. And you're going to see we're going to get a little pattern of that for a while in this logic. So I don't want to call these trick questions, but they are difficult. Okay, 1-2, 1-2. So let's look at 1-2. Jack did his homework. Okay, so we know that Jack did his homework, right? So he did his homework, but we have no idea if he fooled around or not. So do we know he's going to get an Xbox? We don't know. And we don't know he didn't get an Xbox, right? He might have gotten an Xbox. We don't know. We only have a little bit of information, so there's no way to tell. Okay, Jason did not fool around. All right, he didn't fool around, but I have no idea if he did his homework, and the and requires that both are true. So he may have gotten an Xbox, we don't know, but not according to this statement. In other words, this statement does not guarantee him one. I don't know that he didn't get an Xbox because I just don't have enough information. So again, sorry here, no way to tell. And this should have said Jason, so let's fix that too. Sorry about that. That should say Jason, right? Okay, 1-4. Drew did not do his homework. Okay, so he didn't meet this condition. He didn't meet the hypothesis here. So we have no idea what's going to happen. He might have gotten an Xbox. He might not have. We don't know. This doesn't say he's not going to get an Xbox. It says he definitely will get an Xbox if he does these two things. So that's no way to tell. Okay, Julio did his homework and did not fool around. So finally, Julio did his homework and did not fool around. Finally, we have both conditions being met. So we absolutely know he got an Xbox. Okay, Malik got an Xbox. So he got an Xbox. What does that mean? Well, he may have gotten an Xbox because of this statement, okay? But he may not have, okay? He may not have. He may have gotten it for a different reason. Just like when we did detention in class, where it may be for a different reason. So believe it or not, there's no way to tell what happened here, okay? We don't know any of these things actually happened because he may have gotten an Xbox for a different reason. Okay, and then it says here Malik did not get an Xbox. Again, we don't know what happened, so really there's no way to tell. There's no way to tell, okay? Because we know he didn't do, there's no way he did both of them, but it says Malik did not do his homework. Well, I don't know that that's true. And it says Malik did not fool around. I don't know that that's true either. Okay, one of them has to be true, but I don't know which one would be true. It could be either one. So again, kind of a trick question there. All right, so given the statement, then this one's a little different now. Right now we're dealing with or. We're dealing with a disjunction here, right? This is or. So this is going to make it a little different for our results, and you'll see as we compare them. So Bob fooled around, which means, right, it says don't fool around. So Bob fooled around. So according to this statement, they're not going to guarantee he gets an Xbox, but he might have gotten it for a different reason. Okay, so again, there's no way to tell. Jack did his homework. Okay, so Jack met this condition. He did his homework. We don't know if he fooled around or not, but it actually doesn't matter because or says, look, you only have to do one or the other. So we absolutely know he got an Xbox, okay? So Jack did his homework, so we know Jack got an Xbox. Okay, this one, Jason did not fool around. Same thing, he did not fool around. He met this condition. We don't care if he did the homework or not because it's an or. Or says you just have to do one of them. Okay, so if he did not fool around, then we absolutely know he got an Xbox. Okay, Drew did not do his homework. All right, but he may have not taken the garbage, sorry, but he may have fooled around or he may not have fooled around. So we actually don't know because he didn't meet the first condition and we don't know about the second condition. So Drew, we don't know. We don't know what happened. Okay, 112. So Julio did his homework and did not fool around. Julio did his homework and did not fool around. So he did both. That's okay. So he got an Xbox. Even though he did both, he only had to do one. It's fine. Okay, Malik got an Xbox. All right, again, this is a no way to tell because just because he got an Xbox, this guarantees he gets an Xbox if he does these two things, but he could have got an Xbox for a different reason. So again, this is no way to tell. And Malik did not get an Xbox. Again, there's no way to tell. We know he didn't do something, right? He couldn't have done his homework. Actually, I'm sorry. We do this. I'm mistaken. We know he did not do his homework. Malik did not do his homework. I'm sorry because this is an or. I was answering the question for an and. Be careful. So for an or, we absolutely know he didn't do either one of these things, right? He did not get an Xbox, so that means he didn't do his homework. And we also know that he definitely fooled around. So this is not true, right? He did. Because had he not fooled around, had he done what they asked him to and not fooled around, then he would have got an Xbox. We know he did not get an Xbox. So we know that he did fool around, okay? And that's it. That's it for 114. Okay, so let's go to the next slide. So there's a couple of hints here that we went over in class. So extend lines. Let me show you what that means. So anytime you get a diagram like this, you want to extend the lines. See, make them go further. Okay, and also go further this way. this way. Okay. Now, unfortunately, when I go further here, I'm going to knock out the C. So what I'm just going to do is put a C back here. Remember, C is not the angle, right? Nor is B, nor is A, nor is D, right? These are points. These are points. Okay, the numbers are angles. Okay, so it says name two pairs of vertical angles. Well, every time we have two lines intersecting, so that would be like here, 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 and here, we form vertical angles. But at some of these junctions here, some of these intersections, we don't have enough, there's not enough angles numbered here, right? So it's hard for us to use vertical angles here, but here we can, okay? So there's a couple choices here, angle 7 here, and across from angle 7 is angle 8, right? And the big X across from each other. So angle 7 and angle 8 are vertical angles. And over here, we don't have any at all, so we have to do 10 and 9, okay? So angle 10 and 9. Okay, name two sets of linear pairs, right? So two groups of linear pairs. So any of these that are next to each other. So 5 and 6, 4 and 3, 2 and 1, 7 and 9, 10 and 8, 10 and 7, 8 and 9. Okay, so I'm going to take some random ones. I'm going to take 10 and 7. And then I'm going to go over here and do 2 and 1. Okay, but there's a lot more linear pairs. So normally when two lines meet, you form 4 set pairs of linear pairs, right? So 4 sets of linear pairs. But they're not all numbered here, so I can't get 16 of them. There's not that many because, or I should say there's not that many labeled, so we can't name them, so we can't list 16, but there could be up to 16. Okay, name 3 pairs of corresponding angles. So corresponding angles happen when you are in the same position. So what do you mean by that is like upper right. So if you look at the 4 angles around here, these 4 angles that were formed by that intersection, the upper right and upper right, those are corresponding angles, right? So angle 2 and angle 7, okay? There's more here. There's angle 1 and angle 9. So I'm going to pull out angle 1 and angle 9. Angle 1 and angle 9 are lower. Let me do different color. Lower right, lower right. So of this group of 4 up here and the group of 4 down here, they're both the lower right for both of them, okay? And that's it because I don't have enough numbers here to do more. So I have to come over here and force go over here, and I could do 4 and 6. Now, these are not congruency marks. They are in the textbook, but I'm just showing you angles with these things, right? So don't be confused that they're congruency marks. I'm just trying to show you the angle. If they were congruent, we would use, which they're not, we would use that symbol. That would be congruent. I'm just marking the angles, which is why I don't like the way the book does it, and I'd like to do it this way. Because I like to just mark angles to show you where they are. So 4 is bottom left of these 4 angles up here, and 6 is the bottom left of these, so those are corresponding angles. They're always in the same position. And remember, I said this in class too, you know, 2 and 1 can't be corresponding, they can't be alternate interior, they can't be same side interior, because they're at the same vertex, right? You have to go from one group to another group. Same thing over here, 4 and 6. See, they don't share the same vertex. They don't share the same dot here. So that's how it's some angles from this group with this some angle from this group. Whenever we do like 4 and we do 5, we do 6. We didn't have same side interior here, but if we did, same thing, okay? All right, name 3 pairs of alternate interior angles. Okay, so alternate interior means that they're on the other side of the transversal. So one of the things we talked about here when comparing, highlight, see this? Highlight 2 lines and a single transversal. Highlight 2 lines and a single transversal. So I'm going to make this transversal. See, there's a transversal, and I highlight it. And then I highlight the 2 other lines the same color so I can see, right? I can see like this is the interior. See, that's the interior. And out here is the exterior. See, this is the exterior. So by highlighting, I'm going to erase that though, just so I can see everything. But by highlighting the 2 lines and then the transversal that cuts through them, I can easily answer questions like the alternate side of the transversal and whether it's in the interior or not, okay? So that's what I'm going to do here. So I need to know alternate interior angles. So alternate sides of this yellow line. So 10 and 1 are an alternate side. So is 1 and 8. So is 2 and 10. Okay, they're all on alternate sides, but they also have to be in the interior. Okay, so 1 and 10, those two angles are on alternate sides of this yellow line, and they're in this interior region, right? The region between the other two lines. So that's how I know they're alternate interior. So that's angle 1 and angle 10. Okay, now I'm going to take away these highlighted lines, okay? And I'm going to do different lines. So if you look here, we can consider this line to be a transversal, see? And then these two lines to be the two lines that got transversed by this transversal, see? So you can see that these two green lines, now this is the interior for those two green. So for L and M, lines L and M, that's the interior. Here's the exterior, and here's the exterior. Okay. Oops, I want to go back and do that. Okay. So I want alternate interior angles. Well, here's the transversal. The yellow line is the transversal. Alternate sides would be like 7 and 6 are on alternate sides. 5 and 9 are on alternate sides. 10 and 6 are on alternate sides too, but they want alternate, whoops, here, alternate interior. So 7 and 6 and 9 and 5. Seven and 6, 9 and 5. Okay, name 3 pair of alternate exterior angles. Okay, so again, I'm not going to redo the highlighting the lines, but we'll start with this one. So alternate exterior would mean alternate sides of the yellow line and on the exterior. So this angle 10 right here would be alternate exterior with this angle, but we don't have a number there, so there's no way to name it. Okay? And another one would be 8 and this angle. Those are alternate exterior angles, but there's no way to show that, okay? I mean, there's no numbers here, so we can't really name that. So the only alternate exterior angles we can name here are 8 and 2. Now, this is using the original lines, right? If you want me to bring them back, I guess I could, which is right here. Okay, so just to switch gears again and show you how it's done, right? If I put these back, now you can see that 8... See, here's the interior when we're looking at those lines, right? So now you can see that 8 and 2 are on the alternate sides of this yellow line, and they're in the exterior. So that's angle 8 and angle 2. 9 and this angle would also be alternate exterior, but there's no name there, so we can't really name it, and there's not enough letters to name it. So to be honest with you, we can't name these two. So it's kind of a trick question, not intentionally, but we can't name those two because we didn't put enough numbers around these problems. Okay, name the relationship between 2 and 7. So 2 and 7 are corresponding, right? I think we already listed them up here, so that's easy. So they are corresponding angles. Okay, name the relationship between 8 and 7. 8 and 7 are vertical angles. There's a vertical angles. They're across from each other. Remember, vertical angles and linear pair are all hovering around the same vertex. They're all in this group together, or these groups together, or these groups, or these guys in that group. Okay, name the relationship between 6 and 1. So 6 and 1 have no relationship. They're not vertical or linear pairs. They are not connected at all, right? They don't share the same line. So angle 6, let's take a nice blue color. So angle 6 has these two lines as its side, see? And angle 2 has these two lines. So none of the lines are the same, so there's no transversal. So we just put DNE or NA, not applicable, whatever you want to do. Okay, so for the next problems, we're going to erase all of our work here, just so we can see the diagram clearer. And we're going to put in some numbers. So if the measure of angle 7 is 100, and the measure of angle 2 is 85, okay, tell me what the measure of angle 8 is. Well, 7 and 8 are vertical angles, and vertical angles are congruent, which means by definition they have the same measure, so that's 100 degrees. 9 and 100, these are a linear pair. See, they make a line. There's a line. They're a linear pair, so that means they're supplementary, which makes 9 80 degrees. Angle 10 is across from angle 9, so they're vertical angles, so that would also be 80 degrees. And angle 1 would be a linear pair to angle 2 here, okay? And that, I can't scroll down here, so I'm just going to put a little arrow there. So 180 minus 85 is 95 degrees. Okay, based on this true statement, if you are late to class, you will get a detention. Circle all that apply. So Bob got a detention. He got a detention. Okay, was he late to class? I don't know. There's no way to tell. I don't know if he was late or not, because he might have gotten a detention for being late, but he might have gotten a detention for dress code, right? So it could be dress code. Could be dress code. I don't know, so I really should put a question mark there. So there's actually no way to tell. Stan did not get a detention. Stan did not get a detention. Okay, so I know he wasn't late. I know he wasn't late, right? Stan was not late, because had he been late, he definitely would have got a detention, and he didn't get a detention, so that's good. Hal was not late to class. Okay? Well, obviously, Hal was late. Doesn't have, that's silly. So we know that's not true. Hal was not late. We do know that that's true. And that's all we can say. Nothing really exciting about that one. Okay, 11.4. Ralph was late to class. Then we know Ralph got a detention. Okay? We know Ralph did not get a detention. No, that's not true. And there is a way to tell this, so that's not an answer. So Ralph got a detention. Why? Because he was late to class. Okay, and finally some algebra proofs, and then we're done. So the first thing we're going to do here is put the given. We always put the given, and I'm going to try to use a smaller pen, but I might not be able to fit everything here. So that's minus 3x minus 6 equals 16 minus x, and that's given. Okay, the next thing we're going to do is we're going to add 3x to both sides. I think we're going to add 3x to both sides. And that's going to leave me with a result of 6 equals 16. If we add 3x to both sides, that's going to be plus 2x. Okay, so that was addition, property of equality. And then I'm going to add, subtract 16 from both sides. Subtract 16, so it's going to be minus 22 equals 2x. So that's subtraction. We don't abbreviate subtraction because it's going to, we're going to reserve that for substitution. So subtraction, property of equality. Okay, and we're going to divide both sides by 2, right? Oh, which I don't want to show the work. We talked about that in class. So I mean, that's what it would look like if I was doing it. But with a proof, we just show the results. So if we divide both sides by 2, we get negative 11 equals x. And so that's division property of equality. All right. Okay, second one's going to be very similar. We're going to have a distributive property here. So this is going to be negative x. Let's change colors here, I think. So it's going to be negative x minus 18 plus 16x equals 12. That's given to us. Okay, now we're going to do something we haven't done before, although we did talk about it in class. We're going to add the negative x. These are like terms, right? So negative x and the positive 16x. See, we're not adding it to both sides. We're not adding it to both sides. We're only combining two terms on the one side, see? So we're going to get 15x. So we're going to get this negative 18 comes down. So we're going to get negative 18 plus 15x equals 12. And what we did is we added like terms. So you can just say the word simplify, or I like to put add like terms. It's actually added, but I'm going to run out of space here. You can certainly put add like terms. That's fine. Okay, so that's kind of a new one. It's not really a property. It's just something we do in algebra. But we didn't do it to both sides, so you don't want to be saying addition property of equality or subtraction property of equality. Okay, this is an equals, by the way. I'm going to add 18 to both sides, so I'm going to get 15x. Add 18 is going to be equal to 90. So that's addition property of equality. Okay, and then we're going to divide both sides by 15. So that's going to be x equals 6. And that's division property of equality. Okay. I'm going to skip this one. This one's pretty straightforward. You're going to do distributive property, and I will go over that one in class if you have any questions about it. So I kind of want to leave that for you. This problem, though, is fairly difficult. Now, there's many ways to solve this, okay? You can subtract 10 from both sides. Actually, I guess we'll do it that way. But you could also multiply everything by 4. That's also legal. But let's first put the given. That's how I usually teach students to do it, because it's easier on you. But I'll do it perhaps the way you would have normally done it, which was subtract 10 from both sides. So you get a quarter x equals negative 8. Okay, and that's subtraction. I'm not going to fit this property of equality. Okay. And I'm going to multiply both sides by 4. See, I want to get rid of this 1/4. So I'm going to multiply both sides by 4, and that's going to be x equals negative 32. So that's multiplication property of equality, which is multiply both sides by 4. Okay, this one's pretty easy. I'll leave that one in class because I'm running out of time in the video. And I hope this was helpful for you.